Science has entered a fourth paradigm, which is more collaborative, more computational, and more data-intensive than ever before. This is commonly referred to as e-science. At the UT School of Information Sciences, we are working to better enable e-science through effective data management. It is what I call the science of data. The US government has recognized the power of data sharing and reuse to support this open science. The Office of Science and Technology Policy issued a directive to increase access to the results of publicly funded research. To do this, responsible data collection and data handling is important while the research is conducted. Observational data are the basis for ecological studies, and you heard this. They're made at different levels of granularity, ranging from those made by satellites to those made by individual researchers or even citizen scientists. These data often originate from studies conducted by scientists from different range of disciplines. Integrating data across disciplines can be a powerful tool to answer questions such as, how does climate change affect bird migration patterns? To find this answer, data can be integrated from observations of bird populations, land cover, weather, and other large-scale global dynamics. Data Observation Network for Earth, or DataONE, is building a distributed framework and sustainable cyber infrastructure to serve as the foundation for innovative environmental science. DataONE aims to support the access, preservation, use, and reuse of multiple scale, multiple discipline, and multinational science data. DataONE is supported by the US National Science Foundation. The DataONE Federation has members from around the world, including 3 primary coordinating nodes in the United States. One of these nodes is here in Tennessee as a collaborative effort between UT and the Oak Ridge National Laboratory. At UT, we are doing work related to usability and assessment, sociocultural issues, and cyber infrastructure development. DataONE's 4 principles about data were developed by the Sociocultural Working Group, whose leadership is based here at UT. These principles are: 1, data should be a part of the permanent scholarly record and requires long-term stewardship. 2, sharing and reuse maximize the value of data. 3, science is best served by an open and inclusive global community. And finally, 4, the data environment is dynamic and requires evidence-based decision-making about practice and governance. The DataONE organizational chart highlights how the project is structured to encourage participatory design by engaging a large number of researchers in a flexible structure. The UT logo represents locations where SIS researchers are active. The orange circles are locations where our colleagues from Oak Ridge National Laboratory are active. We lead research here at UT, focusing on sociocultural issues related to data sharing and access, usability of tools for data-intensive work and assessments that gauge the knowledge, attitudes, and beliefs of stakeholders. We also work on cyber infrastructure development and member node relations. UT has an active mentoring program for postdoctoral researchers and master's and doctoral students. The DataONE cyber infrastructure is composed of 3 components. Coordinating nodes are the foundation of the DataONE network. These nodes ensure content availability and provide network-wide services. Each coordinating node maintains a complete catalog of the metadata, conducts indexing to enable searches, and provides replication services. Member nodes are a network of data centers, science networks, and organizations, and are an essential part of the cyber infrastructure. The DataONE member node service allows member nodes to expose their data for greater access around the world. The final component is the cyber infrastructure is the investigator toolkit. This toolkit has customized versions of tools scientists are familiar with, such as R, and also has tools developed specifically for the DataONE environment, such as OneDrive. The tools support science in all phases of the data lifecycle. DataONE has identified this data lifecycle, which illustrates the steps of creation and use. It begins when the research is planned and data collection begins. The next 3 steps are the foundation for long-term access. The final 3 steps, in gray, illustrate data discovery and use. The lifecycle provides a context for all phases of DataONE development, including personas. Personas are created by synthesizing data collected from users. They are then used to create scenarios, which are projections of expected user behaviors. In this example, the current data practices are shown in blue, and pink represents where DataONE tools or infrastructure may improve this work. We've talked about DataONE's focus on developing sustainable data discovery and enabling science through tools and services. Another essential element is building community. This stakeholder network illustrates how scientists are the center of activity and the important role that information professionals play. The UT DataONE team is actively involved in helping to build an understanding of the community, its behaviors, and its needs. We've published results of these studies and have seen the results used to inform all aspects of the cyber infrastructure development. The science data-intensive community lacks a workforce sufficient to help scientists tame the data lifecycle. Two of my projects, funded by the Institute of Museum and Library Services, SciData and DCERC, are focused on providing master students with the expertise and experiences to be leaders in the field of science data. Being a part of DataONE is very special. An additional privilege is engaging doctoral students who are now discovering their passion for sociocultural and technical issues related to science data. To paraphrase a famous sci-fi series, they could be the foundation for DataONE, the next generation. Thank you.